Okay, hello everyone, and welcome. Today we're going to keep looking at functions, and we're going to look at the average rate of change. Okay, average rate of change for a function. And our objective is to find and compare average rates of change for different intervals and different functions. Here you see a straight line. The slope is constant between any 2 points on a straight line, but that's not always true. All right, today's essential question: how do we find and compare different average rates of change? How do we do it? Just to review, guys, slope is a rate of change. And again, a linear function, if it's linear, if it's a straight line, it has a constant rate of change. All right, the slope stays the same between any 2 points. All right, and remember, we can. All right, and I'm sorry, guys, I got interrupted there. And remember, we can measure the slope between 2 points. All right, by finding the change in the y's divided by the change in the x's, we can subtract the values, which again, it's rise over run. We can draw a triangle and measure it. All right, slope is a rate of change. We got 2 examples here, and we can compare these by taking 2 points. Like let's say we take this point right here, all right, 60, 20, and take this point right here, 28, all right, and find the slope, the rate of change. We can do the same thing with these. We can probably take like the 24 and the 144, and then so you take the 11 and the 41 and calculate, right, using the ordered pairs. Well, we can see that Sonia's revenue is 25 cents, and the slope of Jackie's revenue is 30 cents. And guys, that means Jackie charges more for cookies than Sonia does. Okay, you can compare their rates of change by looking at points because it's linear. All right, because it's linear, you can look at any 2 points. Okay, another example is just deposit money into a checking account. All right, again, we're comparing a table on this side with a graph on this side. Okay, you pick points from each one, calculate the slope, and find out. All right, the slope of Dave's goes up $12 a week, and the slope of Arturo's goes up $8 a week. All right, also, if you graph it and get the equation, you can find the y-intercept to see how much they started with. But guys, what's most important is that nonlinear functions, they don't have a constant rate of change. All right, the rate of change is changing. All right, so one way to compare rates of change is along the same intervals. Compare like intervals. Okay, find the points along the curve and measure the slope of a line between those 2 points. All right, that happens to be along that curve. That is the average rate of change, but in that interval. All right, again, an investment analyst offers 2 different investment options for her customers. Compare them. Okay, compare from 0 to 10 years. All right, in that case, it looks like investment B is better. All right, 5.75. All right, if you compare for 10 years. Guys, but if you compare from year 10 to 25, over a longer term, it looks like investment A is actually better than investment B. So be aware of that, okay? Make sure you compare different investments over the term that you're looking for. If you need a long term, go long term. If you need a short term return, then calculate using the short term. All right, this is a real good example that I want you guys to understand. These are 3 different functions here, okay? The red function is a straight line. That's y equals 2x. The blue function is y equals x squared. Okay, that's a quadratic shaped like a U. All right, the green function is exponential. All right, it's y equals 2 raised to the x power. Raised to the x power. Okay, that's why it goes through 1 here. All right, this is a good way to compare. Now, this is saying, look at the interval from 0 to 2. From 0 to 2. All right, you see that the red and the blue go up exactly the same. They start and end at the exact same point, so their average rate of change is the same in that interval. Okay, but the green does not go up as much. See, it only goes up 1, 2, 3. Where these go up 1, 2, 3, 4 in the same interval. These have a greater rate of change than the green one in that interval. Okay, compared to the other two functions, the green function has a slower rate of change. As it starts at 0, 1. Oops. At 0, 1 rather than 0, 0. Okay. Okay, so what do you do next? Okay, complete the homework check, all right? And get ready for tomorrow. And this is a very important graph right here. I'm hoping you guys can understand. And the green one is y equals 2 raised to the x power, where x is the exponent. The straight line is y equals 2x, the slope of 2. Y equals x squared, the quadratic, is something we're going to be looking at quite a bit here, starting after winter break. Quadratic is shaped like a U, or an upside down U. Okay? Guys, that's it. Thanks.